Welcome to The Explainer. Today, we're diving into something that's honestly just mind-blowing. We're looking at that exact magical split second where abstract digital state floating up in the cloud reaches down and actually triggers a physical action right here in the real world. And the crazy part? It solves a century-old computing bottleneck along the way. All right, let's start with a bit of a history lesson. Back in a 1966 BBC broadcast called Mathematics in Action, the presenter was showing off a model of Alan Turing's theoretical machine. He made this passing comment that precisely because the machine is so simple, it does a vast amount of chugging up and down its tape. And that perfectly captures what you could call the original sin of computing, having to sequentially scan massive amounts of data just to figure out what's happening right now. So that drops us right into the big question. How exactly do we kill the chugging? Because look, if we're going to safely translate abstract code into real physical movement, like, say, moving a robotic arm or dispensing a cup of coffee, we absolutely have to get rid of this chaotic mechanical scanning. We literally can't afford lag when physical reality is on the line, right? Which brings us to Section 1, the evolution of state. We're basically tracking this evolution of data scanning across nearly a century. So we go all the way from the literal, physical mechanical tape of a Turing machine in 1936 to the incredibly bloated and expensive transaction histories of modern blockchains, and finally, right up to today, to the surgical precision of a 2024 smart contract standard known as ERC 7827. Now, think about how developers have historically visualized data structures. For decades, it's been all about these fractal trees, kind of like a Pythagorean tree fractal. But here's the kicker. The ERC 7827 architecture actually bans this upside-down floating tree metaphor. It literally considers it apostasy. Why? Because you just cannot perfectly control physical reality with unanchored, endlessly reverberating data. For the real world, you need absolute anchored precision. And that leads us to Section 2, the Web3 chugging problem. Historically speaking, trying to map blockchain ledgers directly onto physical machines has been a total mess. Traditional Web3 essentially forces systems to painstakingly scan these massive, incredibly heavy transaction histories just to figure out the current state. So we're basically just recreating that exact same chugging problem the BBC presenter warned us about in 1966, just on a much more expensive, globally distributed scale. So really pay attention to this contrast. On one side, you've got the chaotic, falling dominoes effect of the old first-in, first-out model. It's a mess. If you get a delayed signal or if an event fires twice by accident, the whole sequence just crashes. But then, on the other side, you have the new ERC 7827 standard. It demands strict, bit-perfect, deterministic execution. Zero exceptions, no chaos. Let's move on to Section 3, the LIFO recalibration. By totally ditching those chaotic, floating structures, ERC 7827 relies on a LIFO ledger. Now, LIFO simply stands for last in, first out. It's an architecture where the very last item to go in is always the very first item to come out. This setup gives us a sort of value version control that tracks state transitions flawlessly, and it keeps everything in a super clean, human-readable JSON format. It's basically a bit-perfect mathematical smart contract layer. And because of this LIFO structure, you unlock some wildly efficient single-entry bookkeeping. Imagine an ancient tamper-proof clay seal that they used for ledgers way back in antiquity. By recreating that perfect digital seal today, we can completely bypass the need to chug through massive transaction histories. You literally just check the seal, and you're good to go. This is what we call the chopsticks design philosophy. For years, engineers were just banging their heads against the wall trying to use these bloated, complex smart contracts to move physical objects. It was like building a $1 million robotic arm just to pick up a single piece of sushi. ERC 7027 throws all of that out the window. Instead, it uses surgical, lightweight webhooks and a brilliant little client callback loop built on a 30-year-old internet status code, HTTP 402. It's simple, it's deterministic, and it's crazy efficient, literally like using two simple sticks. On to Section 4, absolute truth at index 0. To really wrap your head around this mathematical engine, picture an ultra-efficient bouncer at a packed nightclub. This bouncer, they do not care about the massive line trailing around the block. They only check the ID of the single person standing right in front of them at index 0 to instantly know who's next. Because of LIFO, simply querying index 0 gives you immediate mathematical proof of state, no ambiguity whatsoever. And what's so great is how pragmatic this upgrade is. First off, it is 100% backwards compatible with the ERC 721 and 1155 NFT standards that we're already using. It also safely reverts updates if you try to overwrite a key without explicit replacement, which stops catastrophic data loss in its tracks. But honestly, the best part? It lowers the barrier to entry. It makes those clunky blockchain queries as easy as standard web requests, meaning everyday web developers don't have to learn some totally alien paradigm just to build on Web3.
Finally, Section 5, Waking Up the Hardware.
This brings us to the semiotic bridge. This is what spans the huge, messy gap between human desire up in the global cloud and strict deterministic machine execution down at the local edge devices. This bridge is what allows abstract code to cross over safely and reliably, completely avoiding those disastrous delays we were talking about earlier. So let's walk through this final sequence of events, right, at the leaf node. Step 1, the LIFO root securely anchors the JSON data on-chain. Step 2, a localized device patiently queries index 0 until it gets a verified state change. And step 3, that change translates perfectly down to the physical edge, triggering the hardware of a localized microhost, something like the open source Cheerbot, for example. Now, inside that unassuming little Cheerbot shell is just a Raspberry Pi. But when it reads that bit-perfect JSON state, it translates it directly into raw electrical signals that fire into its general-purpose input-output, or GPIO pins. These are tiny metal prongs that physically react in the real world. So the verified code literally shocks the leaf node into action. It turns on a light, spins a tiny motor, dispenses an item. Pure math literally becomes electricity sitting right there on your desk. I absolutely love this quote from the architecture documentation because it just perfectly sums up this whole philosophical shift. It says, the human pilot applies the intent, but the agentic cell executes the sweat. By using cryptographic signatures to verify that physical work was actually done, it creates a permanent history, a literal record of sweat, proving mathematically that real, tangible effort took place out there at the leaf nodes. So we've gone from abstract, purely theoretical blockchain state to a grounded, mathematical architecture that totally bypasses a century of chugging. The tech is here. The semiotic bridge from digital truth to physical reality is completely open, which leaves us with just one final question for you to chew on as we wrap up this explainer. Now that the bridge is built, what are you going to program physical reality to do?